Hey, third grade. Hope everybody's doing well. Today's lesson's going to be using our slides that we would use in the classroom, but instead it'll be our YouTube video for the day. So if you could just follow along with your paper and pencil and we can get started right away. All right, you guys. Today we're going to move on from our review from last week and we're going to jump into Lesson 3. Lesson 3's objective is to specify and partition a whole into equal parts, identifying and counting unit fractions by drawing pictorial area models. Just like we would in school, we'll start off with some fluency practice. Rather than doing a sprint and multiplying by 6 for 2 minutes, we will answer 1 through 10 together. So if you could take a look at 1 through 10 and answer those questions. 1 times 6, 6. 6 times 1, 6. 2 times 6, 12. 6 times 2, 12. 3 times 6, 18. 6 times 3, 18. 4 times 6, 24. 6 times 4, 24. 5 times 6, 30. 6 times 5, 30. And I'm sure some of you have noticed the pattern. Regardless of the order of the factor, 1 times 6 was the same as 6 times 1. Both answered gave us 6. 2 times 6 was 12. 6 times 2 was still 12. Regardless of the switch factors, our answer was still 12. It's important to keep our brains sharp and working on multiplication daily. Next, just like we would do on the carpet, we're going to do some group counting. We'll count forward and backward starting from 7s to 70, 8s to 80, and 9s to 90. 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. Let's count backwards, 70 to 7. 70, 63, 56, 49, 42, 35, 28, 21, 14, 7. Next, let's count by 8s to 80. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. Now let's count backwards. Backwards from 80 by 8. 80, 72, 64, 56, 48, 40, 32, 24, 16, 8. All right, and my favorites, 9s to 90, counting by 9s up to 90. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90. All right, and let's go backwards by 9s from 90 to 0. 90, 81, 72, 63, 54, 45, 36, 27, 18, 9, 0. Take a deep breath. That's a lot of counting. All right, our application problem, just like we would in class where we would pass out little pieces of paper and you guys would get maybe a minute or two to figure this out, I would like for you to take out a paper of your own at home, read the problem to yourself while I read it aloud and do your best to solve it. Our application problem reads, Marcos has a 1-liter jar of milk to share with his mother, father, and sister. Draw a picture to show how Marcos must share the milk so that everyone gets the same amount. What fraction of milk does each person get? So there's an important part of this paragraph that we don't want to forget. We need to figure out exactly what are they asking. Well, here's the question mark. What fraction of the milk does each person get? Well, let's figure out how many people we are talking about. We have Marcos, we have mother, we have father, and we have sister. So if I count that correctly, I see that we're actually referring to 4 different people. So it looks like 4 people are going to be sharing this liter jar of milk. If 4 people are going to be sharing this milk, what is the fraction or the amount that one person will get? So I would start by drawing a picture. I might draw a rectangle just to make it easy. And if I'm talking about 4 people, I'm going to give this rectangle 4 parts. 1, 2, 3, and 4. Oops. 3 and 4. Good. Now our rectangle has 4 parts. 1, 2, 3, 4. What fraction of milk does each person get? Well, let's break this fraction strip up into fractions. To take a minute and identify each part of your rectangle. So you should have one rectangle broken up into 4 parts. I'm talking about 1 out of 4 parts, so that is the fraction 1/4. I'm going to go ahead and label that fraction on my rectangle. I'm going to label the other parts as well. Here's a 1/4. There's another 1/4. And there's one last 1/4, totaling 4 out of 4 parts. So if we broke this fraction up, we have seen this rectangle breaks up into 4 fourths. 1/4, 2/4, 3/4, 4/4. So the fraction of the milk that each person gets would be 1/4. Marcos would get 1/4 milk. His mother would get 1/4 milk. His father would get 1/4 milk. And his sister would get 1/4 milk. If you still have some questions about this application problem, feel free to message me on Dojo or on email. I'd be happy to answer or clear up any confusion. We're going to move on. So some concept development for today. My first question to you is, how many equal parts did I split this whole into? Well, you should be seeing the whole. You should see 1, 2, 3, 4 equal parts. What is the fractional unit for 4 equal parts? The fractional unit for 4 parts is called fourths. Okay, fourths. The fractional unit is the word form for the fraction. Fourths. What is each part called? Well, very similar to our application problem that we just completed. If there are 4 parts, then each of these parts should be 1/4. If I shaded 3 copies of 1/4, what fraction is now shaded? Well, in our lesson last week, we reviewed that the number on the top of the fraction is the number of parts shaded, and the number on the bottom of the fraction is the number of total parts. Once again, the numerator is the number of parts shaded, and the denominator is the total number of parts. With that being said, I see 3 parts shaded. 1, 2, 3. So 3 is going to be our numerator. 3 is going to be our numerator. 3 out of 4 parts. Our fraction should read 3/4. 3/4. There are 3 parts shaded, 1, 2, 3 out of 4. How many equal parts did I split the whole into? Let's do a fraction strip. And I'm going to split it right down the middle. How many equal parts did I split the whole into? It looks like I split the whole into 2 equal parts. If there are only 2 equal parts, what is the fractional unit for that? Well, when you have 2 parts, this is 1/2 and this is 1/2. So the fractional unit for this fraction would be half. That is the word form for the fraction, a half. What is each part called? We already answered that. Each part is called a half, 1/2. All right, gotta move on. I'm going to shade one part. Shading, 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 shading. What fraction is shaded? Very similar to our last slide. There is 1 part shaded out of 2 parts whole. That means I am looking at the fraction 1/2. Once again, I have another shape. So it looks like we have 3 parts in all, but only 2 of those parts are shaded. So this is showing me a certain fraction where my numerator is 2 because there are 2 parts shaded, and my denominator is 3 because there are 3 parts in all. This is showing me the fraction 2/3. 2 parts shaded out of 3. Shape number 2. I have a shape. There is 1 part shaded out of 2, 3, 4 parts total. So for this fraction, my numerator, the part shaded, is 1. My denominator, the total number of parts, is 4. This shape is showing me 1/4. Shape number 3. Shape number 3 has 1, 2, 3, 4, 5 parts shaded. 5 parts shaded out of 1, 2, 3, 4, 5, 6, 7, 8 parts total. So we have 5 parts shaded out of 8 parts total. My numerator is 5 and my denominator is 8. This shape is showing me 5/8. 5 parts shaded out of 8 parts total, 5/8. I'm going to now ask you to draw your own rectangle. I'm going to ask you to split it into thirds. How many equal parts do we have all together? So if I have a rectangle and I'm splitting it into thirds, I'm splitting it into 3 parts. Well, if we need 3 parts, I know I'm going to need 2 lines. Let's give our rectangles 2 lines. One line there and another line here. I just split my rectangle into 3 parts, into thirds. 1, 2, 3. How many equal parts do we have all together? 3 equal parts. Now we'll shade one part. Let's see if I can do that. Nope, I don't think so. Let's pretend I shaded in one part. What fraction would be shaded? What fraction would be shaded? Let's pretend that this is a shade. I shaded one part out of 3 parts total. I shaded 1/3 of my rectangle. Now I'll ask you to draw a square. Go ahead and draw a square and split it into 6. Was able to take a moment and split their square into 6ths. So I decided to split my square up into columns. I gave my square 6 parts, 6 columns. The question says, how many equal parts do we have altogether? Well, we split it up into 6ths, so that means we have 1, 2, 3, 4, 5, 6 equal parts. We have 6 equal parts. We're going to shade in 2 parts. So let's see, I'm going to see if I can shade in 2 parts. I'm just going to cover it with this arrow here. I'm going to pretend like I shaded in these 2 parts. Okay. Now that I shaded in these 2 parts, what fraction is shaded? 1, 2, 2 parts out of 1, 2, 3, 4, 5, 6 are shaded. We shaded in 2/6. Next, I'm going to ask you to draw a line segment. So a line segment starts with 2 dots and then you connect it with a straight line in the middle. We are going to split this line segment into 4ths. Very similar to our last fraction, if we need 4 parts, we're going to give this line segment 3 lines. So here's line number 1, line number 2, and line number 3. We now have 4ths. 1, 2, 3, 4. How many equal parts do we have altogether? Well, we have 4 equal parts. Let's shade in 3 parts. Once again, I'm going to just use a arrow shape to pretend like I'm shading. 1, 2, 3. Let's pretend like I shaded in that many parts. I shaded in 1, 2, 3 parts out of 1, 2, 3, 4 total parts. We shaded the fraction 3/4. Now we are at our problem set slide. This is the part of the lesson where you guys would typically grab your problem set packets and work independently back at your seats. Of course, we don't have our problem set packets at home, so we are going to try our best to complete some of these problem set problems, on our own with some loose leaf paper and a pencil. So we're going to look at number 4 and 5 today. Number 4 says, each shape is one whole. Divide and shade to show that given fraction. So it's asking you, I'm asking you not to copy the question down, just to do the work down here at the bottom. So I have the outline of a trapezoid, and it's asking me to divide this trapezoid into 1/2. So for example, you are going to take this trapezoid, you are going to cut it into 1/2, Then you're going to identify the fraction 1/2. I'm going to give you a few minutes of independent work time for number 4. You are going to do the same thing for this long rectangle. You're going to split it up. You're going to identify 1/6. You're going to take a look at this circle. You are going to find 1/3. That means you need to split this into thirds and show 1/3. Number 5, each shape is one whole. This is one whole, this is one whole, this is one whole. Estimate to divide each of these shapes into equal parts. You cannot draw fourths. Divide each using a different fractional unit. Write the name of the fractional unit on the line below the shape. So what it's asking you to do is pick your own fractional unit, it just can't be a fourth, and divide the shapes into that. So if you would like some additional help, I'll give you the fractions that I'd like for you to show. This guy down here, I want you to show me thirds. I want you to identify 1/3. For our line segment, I would like for you to show me sixths. Show me sixths. You're going to identify 1/6. So you should have 6 equal parts on this line segment. If I could make this bigger. And for our circle, I would like for you to show me eighths. You're going to identify 1/8. Okay, and that's if you just needed that additional help. If you wanted to make up your own fractions and split them up on your own, you may do that. Okay, I'm going to give you guys a second and we'll be right back to review the problem set work. So let's review our problem set. So number 4, we were asked to divide and shade divide and shade to show the given fraction. So we did this one together. We were supposed to take this trapezoid and split it up into 1/2 and identify 1/2 on the trapezoid. Here we have the long rectangle. It's asking us to divide and shade 1/6. So I should have 6 parts by drawing 5 lines. 1 line, 2 lines. This isn't the easiest on the computer. 3 lines, 4 lines, and 5 lines. By giving this rectangle 5 lines, I have shown 1, 2, 3, 4, 5, 6 parts. I am now able to shade in 1/6. I'm showing 1/6. Oops. All right, and lastly, we have our circle. It's asking us to show 1/3. So it looks like I'm going to have to split this circle up into thirds. I know some of us have a hard time with that. What I would always suggest is try to think of that peace sign symbol. When you're breaking up a circle into thirds, it's easiest to make a peace sign. So that's 1, 2, 3. And I am able to identify 1 part out of 3. That's showing 1/3. Okay, and down here, number 5. Each shape is one whole. Estimate to divide each into equal parts. Do not draw fourths. Divide each whole using a different fractional unit. Write the name of the fractional unit on the line below. Okay, so I gave a few examples for those of us that might have needed some direction. So let's start with my rectangle here. I need to split that into thirds. That means I need to give this 2 lines. Once I give it 2 lines, you should see that I have shown, I don't know why that's crooked, I have shown thirds. 1, 2, 3. Now I'll take my part and I'll identify it by writing 1/3. There you go. Now I have my line segment here. My line segment is asking me to show 1/6. So I need to break this line segment up into 6 parts. Once again, I'll do that by giving it 5 lines. 1, 2, 3, 4, 5. Try your best to make your lines straight at home. Like I said, it's a little difficult on the computer to navigate, but in order for them to be truly equal parts, the lines should be, a similar way, um, a similar length away from one another. Anyway, I have attempted to show sixths. 1, 2, 3, 4, 5, 6. I can go ahead and take my 1/6 and I can put it right there. That's showing 1/6 of my line segment. Last but not least, I have my circle that I asked you guys to show me 1/8. So if I have to show 1/8, I'm going to have to split the circle up into eighths. So very similar to a pizza, I'm going to start by cutting it from one end to the next. Then I'm going to do it again. Do it once more. And the last time. Alright, now I'm looking at a pizza or a circle, and I can see that I have broken it up into 8 parts. I can take this fraction and I can cover it to show that this part equals 1/8. Once again, if you guys have any questions about the couple questions that we did for our problem set, please go ahead and email me personally or send me a message on Dojo. Come to the end of our lesson, typically we do an exit ticket. So instead we'll do an exit ticket together. Number 1, it asks us how many sevenths are shaded. So I have this picture right here, and there's a few parts shaded, 2 here and 2 here. So it looks like I have 1, 2, 3, 4 sevenths shaded. So if I had this paper in front of me, I would just write the number 4 here on this line. Very easy. Number 2 says circle the shapes that are divided into equal parts. So remember, an equal part, all the parts have to be the same size. So if I look at this pentagon right here, it's cut up into halves, and both shapes are divided, or both sides are equal parts. It's divided into equal parts. So I can go ahead and I can circle that one. Oops. Well, let's pretend it got circled. Next, I have this shape here. It looks like it's divided up into 1, 2, 3, 4 parts, but the parts definitely are not equal. They are not equal. I cannot circle that shape. And lastly, I have this 1, 2, 3, 4, 5, 6 part figure right here. It's a shape with 6 parts. All the parts are the same. They're all triangles. They're all the same shapes. This has been divided into equal parts. I can go ahead and I can circle this shape. Let's see if this one circles. Nope. Okay, well that was our exit ticket for guys. Today. This is the homework that would have technically gone with the lesson that we did today. So what I'm going to ask you to do is to have a piece of scrap paper out, and you don't need to copy down the questions. You can keep this screen paused while you work. And I'd just like for you to relay the answers down that you get on your piece of paper. So for number 1, I'll read it aloud. Each shape is a whole divided into equal parts. Name the fractional unit and then count to tell how many of those units are shaded. The first one is done for you, so you shouldn't have to copy this one down. So it looks like we're talking about fourths. We have 1, 2, 3, 4 parts. We're talking about fourths. 2/4 are shaded. 2/4 are shaded. That is correct. For this one, if you would like to try to draw that picture and shade that in, go ahead. It looks like it's 1, 2, 3, 4 parts shaded out of 5. You can go ahead and do that. Or you can simply write the answer down. So it's asking to name the fractional unit. Well, we're talking about 1, 2, 3, 4, 5 parts. So our fractional unit would be fifths. So you could write fifths. You could write number one, fifths. You can just bullet it, you can number it, however you would like to write it on your paper. The next line asks us to count and tell how many of those units are shaded. So we're talking about fifths. We have 1, 2, 3, 4. 4 fifths are shaded, just like in our example. We would write 4 fifths are shaded. And you're going to do that for this shape, and you're going to do that for this shape. Don't get tricked. There's nothing shaded here. Number 2 says each shape is one whole. Estimate to divide each into equal parts. Divide each whole using a different fractional unit. Write the name of the fractional unit on the line below the shape. So let's break this down. Each shape is one whole. Got it. Estimate to divide each into equal parts. So it's not telling us how many parts. It looks like that's up to us. Divide each whole using a different fractional unit. Okay, we have to use different fractional units. Write the name of the fractional unit on the line below. So if you decide to divide this into halves, thirds, fourths, fifths, sixths, sevenths, eighths, ninths, tenths, you can do that. But you can't do it for this and you can't do it for this. These all have to be different fractional units. It's just asking you to break this up into equal parts. So for example, if you would like some direction, let's make this fifths, let's make this thirds, and let's make this eighths. That's only if you would like to take my direction. If you wanted to do your own equal parts, please, please, please do. And lastly, number 3. Number 3 is a word problem. Let's read it. Anita uses one sheet of paper to make a calendar showing each month of the year. Draw Anita's calendar. Show how she can divide her calendar so that each month is given the same space. What fraction of the calendar does each month receive? Okay, well, we're drawing a calendar, but not really. We're actually just going to draw a shape, and that shape is going to depict the fraction for her calendar. So we actually have to know something that's a little bit outside of math in order to complete this problem. We have to know that on a calendar there are 12 months in the year. So we need to divide her calendar so that each month is given the same space. So what I would suggest drawing a long fraction strip. I would suggest breaking it up into however many months in a year there are. There are 12. There are 12 months, so you're going to break this fractional strip up into 12, and then you're going to tell me what fraction of the calendar does each month receive. We're halfway to the answer. All I'm going to ask you to do is write 3 and then write the answer next. All right, and that's it for me today for math. Thank you all for logging on to the video and doing the lesson with me. I look forward to talking to you guys on Zoom this week. Keep a lookout for that conference link that Miss Pickett will be putting out on Dojo. I miss you all very, very much, and I hope to be with you all soon. See you next week. Bye.